startup.
How's it going? My name's Nathan, for those of you who don't know me. Just out of curiosity, who here, by a raise of hands, knows what Brandeis 3-Day Startup is? Okay. How many of you know that it's happening this weekend? Wow. Okay. Wow. All right. So it is. I've been a part of it for the past 3 years, and now I'm helping to organize. And the most successful that it's been is when we merge all of the Brandeis community, from artists to English majors to co-sci students to mathematicians, whoever. And this year we understand that there might have been a scheduling conflict with a hackathon in Maryland. I'm not sure who's a part of that, but if that has affected whether or not you applied, we wanted to let you know that if you apply in the next couple of days, you are absolutely more than welcome to join us for the weekend. It is unbelievable. It's a high energy startup atmosphere, and you're not just dealing with co-sci students, but business students as well, master's students. We have some really amazing mentors that are coming for the weekend. Some of our judges are Pito is one of them. And our judges are very high-profile entrepreneurs in the Boston area, and they come to give you advice on your startups and also for you to network with and bounce ideas off of. So if this is something that you have an interest in, please take a look at our website, and if you have any questions for me right now, please feel free to ask. Yeah?
My teammate was trying to sign up for yesterday, but he couldn't through the website.
So because the application had officially closed a few weeks ago, it was not accepting responses, but as of this morning, I've changed it, so it's now accepting responses again. Any other questions?
Can you tell a little bit how it works, really briefly?
Yeah, absolutely. So basically everyone comes in with a clean slate, and you brainstorm ideas together. It's not an accelerator, so you don't have an idea. I know you might be working on things in Pito's class and elsewhere, but it's a completely clean slate, and you brainstorm together, and everyone pitches their ideas to the group, and then about 6 or 7 of the best ideas get chosen and voted on, and then you work on those for the weekend. And mentors come in and help you. Food is provided the entire weekend, coffee, there's all sorts of giveaways and help. It's a really amazing injection of startup life. And
what's the objective at the end?
The objective at the end is to come up with a detailed business plan and product and to pitch it to investors. Maybe have a prototype, but it really depends on your group. And yeah.
Can we take an idea from our class?
Yeah, so if you are more than welcome to take an idea you have and even have been working on. We cannot guarantee that it's going to get chosen, and also be open to the fact that other people are going to have to join your team that you don't know, or at least have just met. So we recommend, because of that, and if you're considering going with this in the future, you might want to take some of those ideas that are on the back burner that you just maybe been thinking about and haven't actually started working on. Yeah?
How many people are usually involved?
So we cap it at 40. So it's about 6 or 7 teams, depending on how many ideas are chosen. So you think probably around 7 people per team. Does anyone else have any questions? No? Okay, well, I left, in case you had wanted more information to apply, I left some cards on the back table. Don't feel obligated to take them if you're not interested. But yeah, thank you for your time. I appreciate it.
Thank you.
Have a good day.
So I see we're talking about architectural topics today. My proofreader was off for the weekend. Who knows that Obamacare closed for the first enrollment last night at midnight? All right? So I just put this video. It's about 3 months old. It's really good for a geek. And it describes this very senior software engineer's analysis of all the reasons why the first Obamacare launch might have gone totally sour, as you all know. And I mentioned this in the context of the topic for today, which is scaling and performance, which is a huge topic. And I'm not going to possibly do it justice today, but I want to sort of touch on the things and give you kind of an appreciation of why, when you go beyond your one-person app and you have your friends and maybe even the Brandeis community to something that takes off like Flappy Birds or like take your pick, that the game is quite different. And often the considerations that make the site work at all are totally foreign to what we've talked so far. And they may require you to structure your application in a totally different way, and may require you to break it up in different ways. So let's talk a little bit about, everybody give me your opinion about what kind of reasons there might be why the healthcare.gov site had such a hard time coming up. And by the way, who knows who can say what happened yesterday? Who's in touch with the news outside of the bubble here? Yes.
I think they had 7 million people sign up and 3 million before the cutoff or something like that.
Right, so a huge number of people signed up, but something for me even more interesting happened. Okay, even Miranda is in the bubble. The site was down for like 5 hours yesterday.
Oh.
Yesterday, in midday, it was down for hours. Now, think a little bit of how that might happen. You have the best of the best software engineers at this point, from Google and Facebook and all that, sitting around making sure that this thing is totally as good as it can be, and it still comes down. Yes.
I think the server was just overloaded. So
The server.
All of the last servers.
There's probably hundreds and hundreds of servers.
all of them.
All of them went down at the same time.
Not went down, but I think the overcrowding caused some other thing to break,
Yep.
and that was it.
Yep. Anybody want to go a level deeper? Just guess. I mean, I don't know the answer, by the way. Republican hackers. By the way, not out of the question. Okay. Denial of service attacks is exactly what they could do here. What's a denial of service attack in this context? Yes, Ken.
You flood the site or the server with requests.
Yeah.
To block out everything else.
Yeah, and there's requests that are actual requests, i.e. that actually make it through the server. And as we know, Sharat, there's also requests which don't actually make it to the server and yet trick the server into trying to open a connection and gets it so busy just trying to pick up the phone that it can't get any more calls in. So denial of service, I don't think it's a crazy idea. It's sad to say, but I don't think it's a crazy idea, given all the other dirty tricks in politics. There could have been a physical problem. I mean, there could have been literally an outage, but I think that's very unlikely. What kind of things would you do to protect yourself against a physical outage? That is, a computer that literally gets so hot it fries itself and it crashes. George?
Replication.
What is replication?
You have the same functionality and or the same data on multiple computers, devices, whatever.
Yep.
And you have some non-centralized system to, like more or less randomly or by some rules choose which of these replicated things will actually serve the request.
Exactly. Usually the word replication brings to mind databases, but the more general term is redundancy. Okay, I'm not saying you're incorrect. I just want to sort of give you.
I was searching for this word.
Yeah, it's English. Well, what do you say it in German?
No, it was redundancy, but I was not remembering redundancy, and that's what I said.
I know. I was going to say there's probably a word in German that you would know.
The redundancy, redundancy.
So yeah, redundancy at all levels is the key. That, from the power systems, electricity, to the heating systems, to the network bandwidth, the pipes that come in, to the peering arrangements, to the databases, to the computers themselves, to the geographic locations, i.e., you may have a tsunami here, so let's have one on, or an earthquake in LA, let's say, so let's have one in Baltimore as well. I mean, this is what large, huge scaling systems have to go through to think about how to handle huge loads. And by the way, I really recommend this video, but I'm not going to go through it now. But I'm not going to be able to teach you that right now, because basically I don't know it either. I know it at the high level, because it's a specialty in of itself. And people that know how to do this are are very, very rare. But what I want to try to do is to get you thinking and developing an intuition about where your potential scaling problems might be, or as you think about an architecture for your product, or an architecture designed for your protocols, or designed for your REST APIs, or even your forms and even your databases, to intuitively say, if I do this, or if the load has the following characteristic, I might get a problem. Okay? So, I'm going to turn this off for a second. Do what I want? Yes. And this? Yes. I'm going to try to do this from memory, because I drew it at home. But, I'm going to make a little diagram here. Okay, here we go again. Same game. I think I have a good one in the bag here. Okay, so. Keep drawing. What's that? Okay. This is a diagram of Einstein's, the cafeteria in Shapiro. Rough diagram. Okay. Okay, now let's say you're the manager of Einstein's. And can you see that it's a diagram of it, more or less? People come in here. They're standing in line to get in. Okay? This is pickup, PU, because you're picking up coffee here. Pick up, that's the impulse items, more pickup, a checkout, another checkout, a checkout service. Okay? Now, imagine that you see a long line forming here. And you're the manager, and you want to try to figure out why that is, or what to change to have not have a long line. Or imagine if you find out that you can only, that there's a, between 12 and 1, there's a, n number of students that want to, or people that want to get food here, but I can only serve n over 2. So what are some of the considerations I would do to analyze this problem? Yes, Bert.
We need to see where it slows down.
Okay, say more. So you want to you need to measure, right? Measure. Yeah, go on.
So if you could select point to see, like count how many people are passing through each point,
Yeah.
like see the rate,
Yeah.
and see if they get stuck on service or checkout.
Yeah. So okay, anybody want to add to that, David? You're the manager. You see lines forming. Really, because it's simple if you look at it intuitively.
More checkouts.
Huh?
More checkouts.
More checkouts. When would more checkouts not help? Yes, go ahead.
We need to calculate the ratio. Making coffee might be slower than checkout, right? So we need to calculate the ratio of the speed. And if the making coffee is 5 times slower than checkout, we might need 5 times personnel in the making coffee.
Yeah.
And make sure the speed of checkout and the speed of making coffee is the same.
Well, there's many more things, right? You're making bagels. You might be making, I don't know what else they're making over here. Toast. There's toast. There's a toaster here. Right? Yes.
You need a sense of the finances to know what you can afford to change.
Okay.
Like if adding an extra employee costs you an extra $20 an hour, but only makes you
Good.
an extra $5 an hour,
Right.
an extra sales, that's
Right.
not worth it.
Yeah, that's good. Anybody else? That's a good point. Yes.
You need to know how long people are willing to wait.
Yeah. And how would you tell that?
You probably do a study, see when they walk away, or do a little survey, see when they get angry.
Yeah, just the people that abandon their quest, right? Exactly. How would you? So as I was thinking about this, the other thing I thought I would do is I would draw kind of a flow chart, because one thing I want to know is somebody comes in. Oh God, I did this all on paper. Didn't bring the paper with me, so see if I remember to bring it with me. No, I did not. No. But you know, they may pick up something and then just check out. They may order something and then pick up something and then check out, or they may just check out. They may want just coffee, but with coffee they actually check out first, if you remember. So at this, some percentages leave and some percentage pick up coffee. Let's call this PUC. And if you start looking at this, you start thinking about, oh, now I need to know the percentages that go through each of these queues in a way. Yes?
Well, also, it could be helpful to have kind of two lines, because
Yeah.
there's some transactions that be really quick,
Yeah.
like coffee. You
Yeah.
just give people a cup, and then they
Yeah.
go fill up the coffee.
Exactly. In fact, if you, at least I haven't been there in the last, actually, couple of months, but recently, this checkout would only let you check out of coffee and soda, pickup items. You couldn't check out here for ordered items. So you could also designate a checkout for a certain purpose. You may also decide that actually the problem lies here, people are all crowded here, and adding another coffee machine is what you need. You may discover that the coffee machines are running out, and you need to improve the flow of coffee to the coffee machines if you were making the coffee. The point is that this is a lot like the line of thinking you go through if your healthcare.gov is not responding quickly enough, if it's crashing. It's to think about the moving parts in there, what the rate of requests that are coming to the particular part of the system, how fast, how much of the queue that exists is caused by that, and just think about from the perspective of not the individual response time, like how quickly does it when I refresh the page, how quickly do I see a page, because that is important too, but that's one user's experience, to the system's overall response time. So that's for me, that's an easy way or a way to realize that we have an intuition about this stuff, and the same intuition applies to thinking about that. Coffee shop applies here. Okay. So when we're talking about optimism, yes.
Are there really that many factors, though? I feel like there's more factors than Einstein's involved than there would be the thing. Isn't like a simple solution just to always add more servers? Isn't that what we would do?
No, and no.
Okay.
Not only is it not a simple solution, but it's not what people always do. Because sometimes you can change a few lines of code or add caching somewhere or remove an option. I mean, remember what I told you guys? I don't know if you remember that when I'm typing into the browser and I type Brandeis and it says university, and it knows what I'm going to type next, that the browser, I'm going to touch on this, the browser actually is beginning to request the page for the Brandeis University homepage before you've picked university. Okay? So now this is anticipation, which is a whole other thing which is possible. Anticipate what they're going to do. You can also have you guys heard of this book called Nudge? It's a great book, and it's about designing systems which nudge the users into doing that which you want them to do. So simple example, when you go to a job, does the job ask you to check a box if you want to have a retirement plan, a 401k plan, or does it ask you to check a box if you don't? And if you think that what you want is to encourage people to have a 401k plan or an insurance plan, you nudge them by the defaults you offer them. Again, intuitive, but tested by research to be unbelievably powerful. They get into things like health food, like how do you get kids in school to eat more healthy? And it could be simple things like putting the healthier foods at eye level and the less healthier foods at not eye level. So there's a lot of things like that which do not involve adding servers, but involve thinking carefully about what's going on, and importantly, measuring. Okay, one of the cardinal sins of improving performance or scaling or optimizing, cardinal sins is to start optimizing before you know what the problem is. Okay, because experience has shown that almost always your guess about why your system is slow is wrong. And so you don't start putting in caches or redundant databases or extra servers or extra app servers or whatever until you have measured and demonstrated that that is where your problem lies. Okay, so the process of optimizing and scaling. Hello guys, what are we doing here? Close the computer, please. The process of finding that is the process of discovering bottlenecks and eliminating them one after the other. Okay? Now, of course, what happens is that when you remove one bottleneck, you see the next one. You remove one, you see the next one. And you have to have your eyes on the prize. You have to be thinking about, when is enough. And people often say that it's a good idea to decide ahead of time what the performance is that you will find acceptable. How many, customers per hour do we need? That's why there was so much focus on the target number of Obamacare, 7 million. That's why I'm sure people were calculating exactly what they believed the likely traffic would be coming into the server over the last 24 hours, and designed their systems to be able to, at least in an intellectual way, be able to believe or make the claim or demonstrate that it would that it would be able to handle it. But often, of course, that stuff is just, you don't find out until you try it. Okay, so it's the finding and removing of bottlenecks one after the other, and it's basically focus on measuring. And measuring can be very, very simple. Okay, measuring is not something grandiose. Often it's as simple as a stopwatch. Often it's as simple as creating an artificial load with other techniques and then seeing what happens, seeing how the CPU gets pegged to 100%, seeing whether the database server, which also will be able to give you statistics, gets pegged. Okay? So, the worst sin, again, optimizing early. Now, I'm going to jump back to last lecture and talk about server push, because server push is also a technique in terms of scaling. Because think about it, here's the intuition that I want you to develop. Imagine if Teachback, which is supposed to show a graph to the professor, actually it's not a great example because it's not, let's go with what's going on. Imagine what's going on. The only time that you would see whether anybody moves on the map was if somebody hit the refresh button. Okay? Now, in addition to the fact that that's a very bad user experience, talk about the performance and scaling implications of that particular approach. Yes, yes.
Well, I mean, every time someone hits refresh, it's
Yeah.
probably going to have to go and either check where everyone else is, or if it's constantly checking to update it in the database.
Right, exactly. So that's a class, yes.
Can you just rephrase the question? So are you saying that the problem is when you're using the refresh button, or that we want us to solve by not using the refresh button?
In other words, now this was more or less the right answer. What is the intuition, separating usability, which we understand is distinct, what is the intuition about whether it would be acceptable or not acceptable to update the map only when the user hit the refresh button? Yes?
Well, if you only update it on the refresh button, then you don't have to, the server does not have to know how many people are currently watching the map.
Right.
So only when they press the refresh button, then a GET request comes in,
Yeah.
it is served, and then the server immediately forgets about the request that it ever existed. If you have a constant on its own updating map, then the server has to keep a list of all the millions of people who are probably currently watching at a map and sending them push messages whenever something has to be updated.
Exactly. Now, do you have an intuition off the top of your head, or are there further questions about the patterns of use that you would have, about which of those two approaches would turn out to be a better scaling approach? Yeah.
Well, at least from just to offer the other, big trade-off
Yeah.
is just more clicks.
Yep.
Users don't want to click.
Well, that's the usability, but also
Yeah.
more clicks, which I set aside, being I know that it's a bad usability experience, so
Okay.
set that aside for a second. But really, every time you click, you're going to tell the server to do something, and the server. So to me, the question becomes a little bit of the rate of the proportion of people that are going to be impatient and are going to be hitting refresh more often than the data actually changes. You know, in a way, you have to think about what you believe is going to be true. The other thing is how often you will hit refresh while the part of the world that you're looking at hasn't changed, but another part might have. Okay, because you're looking at a map, you're zoomed in on Volan, but meanwhile, 2 miles away on our huge campus, people are moving around, but it doesn't matter. Yeah.
For the record, we have both, but that doesn't matter.
Yeah.
Find My Friends only does it when you're searching.
Yeah.
So that's not a refresh button. It kind of is.
Yeah, no, it is. It
so
is.
Find My Friends, is that done badly then because of that?
I would never question what they did. No, I'm sure. I'm speaking sort of, simplistically. I'm sure they would have a reason, but that's exactly on the point I'm talking about. It could be, for example, in their case, that it may be a privacy thing. They don't want the server to always be aware of where you are. They may want to say, Peter was asking where David is, and that's the moment at which I'm going to look. Before that, I don't know. It could be something like that, or it could be a scaling thing that I'm just not seeing. But that's exactly the right point. Okay. So, but you also think about the proportions of people doing each thing, right? I mean, again, it doesn't really map perfectly to what's going on, but is it a matter that every user maybe once every 2 hours needs to see new information, and so it doesn't matter if they have to hit refresh because that's not a big load, or is it a sense like Twitter where you know that the product only works if you're constantly seeing tweets happening, and so you have the thought process is what I'm trying to get at. The idea that every time you do something, you're putting a load on the server. I'm not focused on how quickly the answer can come back. I'm focused on the aggregate load that all these people hitting refresh are putting on the server, and the cost it would be to update that. So in my simple example, but I'll dive into code in a second. It looks a little bit like this. It's the form demo thing. The source is on GitHub, but basically I have one user here, and he adds a comment and hits OK. This tells the server to add, comments +1. And then I have another user, so this is one person here, who wants to see the number go from 4 to 5. And the question is, how does this happen? Right? Because before we get into this question at all, we already have the basic Rails or any web app scenario, which is I click the button, it fires off a request, which happens to be a post request to the server. The server says, a new comment, creates a record in the comments database, and returns a refresh of the list of comments, and you see one more. So we have that already. We have the round trip. One shows the form. The second one displays the updated form and updates the database. Now, if I have a second window, if I have a second window of a second user or the same user where I'm looking at the count and I want that to update, this is a separate HTML page, right? How do we get this HTML page to increment? All right? Now, there's a few possibilities. I could tell this page with a little bit of JavaScript to say refresh yourself every n seconds. You could do that. Every 5 seconds, every 10 seconds. Is that necessarily good? Assuming that the usability is acceptable, is that necessarily good? Or not? What questions do you want to ask about that design before you answer? Yes?
Is the desired refresh rate going to be the same for all users?
That's one good one. Yes? Yes?
What occurs more often, the 10 seconds or changes on the server?
Exactly, yes. Because, I mean, it could be that people are adding comments once every 2 hours because nobody ever comments, in which case you're constantly refreshing these pages for no reason. Yes?
Is the server going to be able to handle that refreshing if
Right.
there is a lot of users?
Right. Exactly. So that's not a great design, although it's acceptable for small cases. It would never scale. If you work with Facebook or Google, they would shoot you if you propose this. Guaranteed. Okay? But it's not, don't assume that everything we do, I mean, it's reasonable thinking as an engineer, and it's kind of like Yagni, only build what your use case requires. If you think your app for the first 12 months is going to only be used by 10,000 users, this may not be so bad. Yes?
I was very pleased when the last Google Tech Talk here
Yeah.
at Brandeis,
Yeah.
where we had one guy who was actually not a software engineer there, but system admin or something.
Yeah.
And he said that Google just deals with the fact that software engineers often don't
Uh-huh.
software engineers think in their little
Uh-huh.
world where
Yeah.
you don't deal with millions of users.
Right.
And then the system admins take their code and
Yeah.
think how to make it scalable.
If you want to work yourself up the technical career path at Google, though, I promise you, you better learn to be an engineer who knows about scale. Because you'll stay in the bottom of the company if you don't. Scale, especially at Google, pervades everything, as does performance. Okay, so what does Pusher do? Pusher takes advantage of a new technology in web browsers called WebSockets. And a WebSocket is a way, and I don't know the implementation details, but let's say that a WebSocket is a way, as in general, a web browser, when you hit refresh, sends a request this way and gets a response back, right? Well, a WebSocket is a way to open it. It's like a second telephone line. It's another line to open a separate channel that stays open, that allows the server to send information to the client. Okay? So it goes the other way. And they follow a model which is very classic called publish, subscribe. Okay? Publish, subscribe, you hear that phrase, and it's used in many different contexts. It's where there is one entity which has events happening at arbitrary intervals, and there's an arbitrary set of other entities who want to be notified when those events happen. In Java, you have listeners. That's a form of publish. It's kind of a static form of publish subscribe, but I'm sure in Java there's libraries to do publish subscribe as well. So what happens is, and I'll show you the code in a second, is that when I hit this page, the browser opens up this connection saying, I'm listening for events coming from this server that are on this channel and are this type of event. And when such a thing happens, a piece of JavaScript gets executed. Okay? Now, whoever said that there could be a problem with the number of pipes. I mean, if I have 1 million users and they're all sitting here, you have 1 million WebSockets open, I'm going to guess, but I haven't researched this, that the architecture for WebSockets is designed to scale well even in that scenario. But I can't say for sure, because the whole point of WebSockets is to create these kinds of channels. So let's look real quickly at the server push code. So first of all, I'm going to, the service I'm using is called pusher.com, and it's got free subscriptions for small load cases like this one is. And basically it says, okay, what I'm going to do instead, since this is Pito's Rails server, I'm going to create a new server whose only job in life is to be extremely scalable, but does only one little thing, which is deliver these tiny little messages. So we have a new server now called the pusher.com server. And whenever I'm displaying a page which I want to have updated dynamically, okay, there's a channel, a back channel, that is opened and kept open that allows it to send a message to all the browser windows, number one. And number two, there's a regular path that allows any, actually it doesn't go from here to here, sorry. It goes from here to here. That allows this server to say to the pusher, something has happened and you want to notify everybody who's listening to this event, who's subscribed to this kind of event, that it happened. So let's look at the code. And the code samples are all inside of here, but I'm just going to show you my code. Okay. So here's form demo. So the first thing I have is inside of app, views, layouts, application, which you remember this is the page that all pages generated by this website are built from by filling in the yield. There's one new line up there, which is this one, line 5, which says bring in the JavaScript libraries for Pusher. That's the first piece of the work. Okay? The second piece of the work is, and this is something that I might explain right now, which I haven't explained before, but in assets, you find a set of files which Rails assembles into let's say a combined huge JavaScript file, a combined huge CSS file, by just gluing these files together so there's only one that gets delivered. And they're all structured like this. There's an application dot, in this case JS, which includes those libraries that you know you require, and this required tree line, which some people deleted because it made things better. Required tree says, look at what else is in this very directory and bring those in as well. Okay? So in this case, what else is in here is categories.js, which is empty. These are all empty, in fact, except for this one. Why are they called .js.coffee, real quick? Because there's a preprocessor to JavaScript called CoffeeScript, which I have personally not used, but people love it. And just like .html.erb preprocesses one and then the other, this preprocesses coffee into JS, which is why my file is called .js, because I'm not using coffee, so it's just JavaScript. A very easy thing to trap to fall into is the comment symbol for coffee is pound, whereas the comment symbol for JavaScript is // So you'll get very strange error messages sometimes saying incorrect line pound is because of that. But this is the code I write. And basically, let's look at this code. So this code gets loaded whenever I'm looking at a page, a view coming out of the items views. So any of these pages have this JavaScript concatenated to them. Did I see a line there? A hand there, rather? Okay. Okay, so here are the lines of JavaScript. Okay, so basically, I'm giving it my API key, and I'm giving, remember, publish, subscribe? I'm subscribing to a channel called Form Demo Channel, okay? And I'm looking on that channel for an event called comment event. And when that event happens, so when the pusher back channel says an event on the Form Demo Channel called comment event happened, this JavaScript gets run. In particular, this function data, curly bracket, this is an anonymous function in Java lingo. It's a function that is defined and called in the same place. So it's a lambda also, if you want to use that lingo. But basically, it says, this function will be called whenever this pusher pushes to me. And here's what it'll do. It'll define a variable called ELTID, which is a string, comment dash count dash, concatenated with data dot item ID. Okay, so in other words, this method, this Java function is getting called with one parameter, which is data, which is just my name, and the data is a hash or a bit of JSON. It has two keys. One key is item underscore ID, and the other key is count. So what do I do again? I say create a variable, which is just a string. It's going to be comment dash count dash 41, let's say, which for me means the comment number for ID 41. And it's a class because look at what I do here. Document.get, it's an ID. Get element by ID using that string, get the inner HTML for it, and I stuff in the count. Everybody follow that? Follow it? Okay. All right. So, where do I have to look next? Where would you go and look next for the next piece of this puzzle? Those of you who follow this.
Server send a message to the pusher.
Right. So if I tell you that I want the number to change whenever I add a comment, where would you look?
Maybe the
Yes.
Comment controller.
Comment controller. Let's go look at the comment controller. Controllers, comments. Okay, here it is. You've seen this before. This is create a comment, blah, blah, blah. Clean the parameters, comments new, clean params. Here I have a successful save of the new comment. I do push count, which is a method. I give it the item ID, which is just this ID, and item.comments.count, so the number of items, number of counts rather, the number of comments on this item. And I call this method, okay? And this method says pusher, that's one of their methods, one of their classes rather. Trigger, here's the channel, there's the data. Check it out, it's called comment event, item ID column, colon that, count, colon that. It's just a hash, okay? And this is happening on the server. Pusher.trigger is calling this thing. and it's saying something happened on the channel called form demo channel. We're going to call this particular message comment event, and this is the parameters for it. Okay? And what else do we have to do? Yes?
So, well, the viewer has to somehow deal with whatever will come back from the pusher.
Ah, wrong. Anybody else? Yes. It's a trick question.
Let your application listen to the channel.
Okay, and I already showed that to you. Where did I show that to you? What are the three words in the English language that, how's it go? That ends in GRY? The answer is? There's only two. What else has to happen? Nothing. It's done. Yeah. Okay, so going back, so where do we tell the browser to respond to this? That was this. That was this. When the pusher event happens, this is calling this bit of JavaScript. This bit of JavaScript surgically alters the DOM of this page and makes the number change.
But it appears to me this JavaScript will be added to every page.
It's going to be added to every page in the view item. And in fact, I did have a post, because there's one technical detail that I don't understand, and I'm talking to them right now about it, which is what is the lifetime of this pipe? How long does this pipe, so this is now gone, how long does this pipe survive? Do I have to bind it over and over again whenever I display any page in the view of the item, of the, because it's called items.js, of the items view, so that whole collection of views that belong to items? Do I have to do that over and over again or just once? I don't know. But the way it's written, I'm doing it over and over again.
Yeah. And by the way, they have, with the free account, they have like a 20 limit.
It's a pretty high limit, though. I thought it was
20?
No, it's more than that. Is it just 20? I thought it was.
Yeah, 20.
Oh.
20 connections.
20 connections or 20 messages?
20 connections.
Oh, yeah. Well, this is just one connection.
Yeah, but if you're defining that to all the views in items.
That's the question. Are they simultaneous or not? I don't know. It deserves more research. I agree. For our purposes, though, it's good. The question is, how long does the connection last, and does each instance of this, and I'm admitting I don't know.
It will last until you close the page.
So do they have their own gem? Is that how
They
you
have their
use
own
it?
gem.
Sure.
Yes, they have their own gem. Correct. As you can tell, not from this, because here I'm in JavaScript.
Oh, but you're still
But in
saying
the other
you
place, I do.
pusher.
Here I see this here, that. Here I am in Ruby, so that's where the gem plays.
But then in the JavaScript, you were still saying, var pusher equals new pusher.
Yes, that's because, but I'm just saying that's not coming from the gem. It's coming from the application, this thing. It's coming from line 5, where it's pulling in a whole bunch of JavaScript to get this to work.
Gotcha.
Okay? So this is a class. So this is an example. You can use this code. It's obviously very general. You can have multiple channels, multiple events. You can send whatever data back and forth you want. And there's even on the if I log in, there's even a debug console where I can see that. Well, I've used it once earlier today, so maybe that, I don't know exactly, there are no open connections right now, and the number of messages per day is extremely small. Well, let's just do this for the hell of it. Let me just go over here and run this again. Oh, right, of course. Only one server at a time. So if I now go, here's one, right? And I'm going to open another window. Actually, I'm going to do it like this. There's the other one. And there's comment 2, right? I'm going to add another one here. Hello world. And there's comment 3. So now if we go back to the pusher page. Oh, there it is. There. See that? Move this. Okay, here we go. There we go. March 28th. Oh, you're right. So where's today? April 1st. Oh, wait, I'm doing it wrong maybe. Yeah, it's interesting that it's not showing up. Anyway, I wouldn't worry about it too much right now as far as why April is not showing up. Because there's a...
If you go this way, more to the right.
Because there's April.
Is it your page? Is your page is not showing? Your page is cut off?
Oh, that's the question. Maybe that's all it is.
When you scroll to the left.
Yeah, that's all it is.
There
Thank
you
you.
go.
Thank you very much.
So it shows now.
No, it doesn't. I
just
just...
saw it.
I know.
You have to drag that bar over.
That bar on the right.
Bar on the right.
It's on the screen here.
This thing?
Yeah.
Oh, there's another bar over here. What the heck is this? Okay,
I think that's it.
enough.
That was
So I have the max. Okay, there we go. Whatever. I haven't studied this, but but that's the general concept. And so I researched a bit. What are the different ways? Now, if you didn't want to use Pusher, of course you could do this yourself, right? You could write another process essentially on your server, which dealt at the lower level with WebSockets and communicated back and forth. And there's gems for that, but it's much more complicated.
But look that we have to do that unless you want to pay for like some premium service.
Okay.
With Pusher.
So be it. Let's go on. All right. So so that's how that works. So quickly about performance. So I mean, when we talk about performance as opposed to scaling, it's important to have the difference to be clear in your mind the difference. Okay, performance is what the user sees. If somebody says your app is slow, it takes me a long time to refresh the page, or when I'm typing into my rich text editor, every time I type a letter, it takes a long time to respond. Or if I'm if it's on a smartphone, then when I try to drag a marker, it drags slowly. Whatever. Those are all performance one user experiences. Now they're not separate, but when we talk about scaling, we're talking about operations per second, users per second, transactions per second. It has to do with how many people total and how many activities total your service can handle. Okay. In the world of yes.
This is a little bit of a non sequitur. I was just kind of curious. So I was just remembering something that came up on a project I worked on once with the perception of speed.
Yeah.
And I don't know if there's a gem for this, or this is I guess it's JavaScript. But,
yeah.
Tracking where the mouse is at
sure.
any given time, and
yeah.
preloading content that is near the mouse.
Yeah. There's all kinds of. I mean, so I allude that as fooling people. I mean, you can also fool people by distracting them. I mean, the difference between having a beach ball versus having something finished but not be really done, or giving you something to distract you, saying N% of your download is over. All those things are kind of gimmicks, not so much to fool, but to relieve the user's impatience with status. Okay? And so often the solution to something that feels slow to a user is you can't make it faster because the thing, after all, is limited by the speed of light, but you can give the user enough feedback that they're satisfied. Okay? Now, that doesn't mean that they're separate. I mean, if you have a scaling problem, it'll be perceived by users also as slowness, but it's more a matter of, like healthcare.gov, how many people an hour can we process? How many people an hour can we log in? What happens if, everybody asks for a change of password? People say, you'll receive the email within a few minutes, and it arrives the next day. That could be, that's probably just a bug, but those are all questions of how fast can you send emails. So you've all seen this thing. I see it fairly often these days, and that's the evidence of some kind of a scaling problem as far as I'm concerned. Yes, it could be a bug, and by the way, of course, one person's scaling problem is another person's bug, right? It becomes kind of a gray area. In fact, the difficult bugs, the ones that go beyond the beginner level, tend to be bugs that are hard to reproduce, that require a large load to have them happen, and that are very difficult to fix because they're not one single, this logic of this if is incorrect. It's something a lot more complicated involving multiple systems interacting with each other. But you've seen this. And basically, I mean, for me, I think about things like how many logins can you do an hour? How many logouts can you do an hour? How many add comments can you do an hour? How many users can you support an hour? How many emails can you send an hour? In systems that are dealing with images, how many images can you compress or uncompress, or how many, you know, in Facebook, how many images can you upload? All those things are scaling questions. Okay, now, in the spirit of YAGNI, and consistent with everything I've said so far, you don't want to go build a certain solution to a scaling problem that you anticipate that might happen. You want to build a solution to the scaling problem that either you know is happening, in which case you're a little late, or that you anticipate will happen very soon. Okay? So, William, it is distracting to me that you're coding while I'm talking. Sorry. So generally think about, you know, what is in each of your products, are you going to be building support for having multiple servers? Are you going to be building database replication? No. Okay, you have no idea yet whether that's needed. And number two, even if it's needed, it may not be needed for 12 months or more, or it may be needed tomorrow. You know, even the ones of you that are planning to build a product that you want to ship and sell, you know, focus on the things that you know you need. Okay? But there's a lot of techniques. And somebody said, whoever said, oh, you just get a bigger server. Ah, yes, okay. First of all, there's not one server. We've established that. Any non-trivial system at all, I mean, is going to have multiple servers. Could be have 2, it could be have 200. In the old days, you know, you literally had to, and old days being 5 years ago, you literally had to go out and buy a server, like literally order it from Dell, configure it, and maybe have it delivered to your office, maybe have it delivered to what they call a colo. Colo stands for co-location, which is a company that basically provides server racks, electricity, an internet connection, and air conditioning. And you provide a server, which generally was one of these you know, rack-mountable servers. And you would buy them, and you would have them shipped to XYZ Colo, and they would install it. And they would say, okay, your thing is up, here's your IP address, go crazy. Before that, you would literally get, and I'm sure at Brandeis there's lots of servers under professors' desks and so on from the old days, but nowadays that's totally a waste of money. And the big problem if you had to build a service like that is to know how much to spend. Because, you know, you could be brilliant by buying only one server because your product is growing very slowly, or you could be really dumb by buying just one server because actually on day 2 you're already totally pegged, and everybody and all the attention you generated because you were hit on Hacker News or whatever goes out the window because nobody can access your server. So the question of how many servers to buy was a very, very you know, important and weighty question. And people would either keep their jobs or lose their jobs by picking the wrong number there. Because the time between placing the order at Dell and having so-called the server provisioned, is what they called it, hooked up, plugged in, booted up, running, could be days, weeks. Now, I say that's all passé, because nowadays nobody really, if you have your head screwed on right, nobody does that at all. Nobody actually goes out and buys the server unless you are Google or Facebook. You end up using one of the various cloud services, whether it's Amazon Web Services or numerous other ones there are, and you're generally not owning a piece of metal. Often, very, very often, you're owning a virtual server, that is the server that is running on a piece of metal. You don't know who else is sharing that machine with you. You don't very well know, you know, if that whoever's on that computer with you is using up the CPU, how it's going to affect you. So you lose a little bit of control. But in exchange, you get this fantastic advantage, which is massive, that you can dynamically grow and shrink based on load. And people do this all the time. You know, around holiday season, triple the number of servers, or we know we're going to be run on Hacker, not that you can't predict, but an article is going to come out in the New York Times about us, crank it up. You can literally dial up the service. And that is where the question of scaling up versus scaling out comes in. Scaling up is the easy one. Scaling up is I have a server, I'm noticing that it is running slow or does not have enough capacity, and I buy a bigger server. More cores, more memory, more disk. Buy a bigger server. Big advantage of that is your software is more or less unaware and doesn't change because of that. Because it's the same software running on a machine that has more capacity. That's called scaling up. It's considered to be the lesser of the two ways to go. Scaling out means that you have designed your system architecture in such a way that instead of having a few big servers, you know, like the classic three-tier architecture, instead of having, you know, maybe you have your app server 1, you have a database server 1, maybe you buy app server 2, maybe you say, no, maybe I can buy a second one, but putting this in is a pain. You got to figure out how to get the software to be the same on both. You got to figure out how they both talk to the same database. Easier is just to say, oh my God, just get another 32 gig of memory and we'll be all set. And this one, get this one another 32 gig of memory and then we'll be all set. Scaling out says that from the outset, you've designed your system so that it is built out of a bunch of small and almost identical servers. Okay? Such that, and when I say you designed it, it's very difficult to design it this way. It means that literally you have a control panel where you can say, here on this IP address, there's a new server that exists has nothing on it. And you click a button and it automatically runs all the scripts and all the installations or whatever else, and importantly configure some global config table that says server 6, I want it to be another DB server. Oh, and now I realize actually server 7, that's going to be another caching server. Oh, server 8, I need another app server. This is called scaling out. You don't buy bigger computers, you buy more computers. And the architecture of your software, this is not easy to do, this is a whole lifetime of experience almost. The architecture of your software allows this to happen, because if you think about it, you know, if I have, very elementary case, if I have 3 rail servers, let's say the first 3 are rail servers, and somebody does a HTTP GET, which of these 3 control or runs? Which one runs? How do you decide? Any guesses? Yeah.
I mean, probably the one with the lowest load.
But how does that even work technically? How does that even create? How do you even do that technically? Yeah. Can you imagine? I mean, you got the right answer. Not necessarily. There's other considerations, but that's the general idea. Yeah.
Well, you can track how many queries are currently processed on each,
Yeah.
and keep them in some kind of list or
Mhm.
stack, and then pop them up once they're done.
Yeah. Yeah. It's true. But there's something. Yes. Go ahead.
There has to be like a dedicated machine which handles the load management.
Yeah, exactly. There's a component that is a well-known component that existed before the whole concept of scaling out and scaling up, which is called a load balancer. And a load balancer is the thing that has the main IP address for your site, and then it decides whether to forward that request to this guy, or to this guy, or to this guy. It's called a load balancer, standard component. In fact, the most elementary and fairly useful kind of load balancer is called a round-robin load balancer. Round-robin load balancer doesn't do any of this clever stuff. It just takes turns. It's the first one, second one, third one, first one, second one, third one. And that does pretty well. Okay? But here already, there's a lot of manual configuration. If I have a fourth thing here, fourth computer, okay, I'm going to be messing around with IP table in here and round-robin rule changes, and it's fairly complicated. If you build a good scaling out architecture, all this configuration and changes and rerouting and so on is being controlled at a higher level. So it becomes much easier and actually doable to add servers depending on what's going on. Sometimes you may need another web server. Sometimes you may need another database server. That's called scaling out. Okay, so and again, this distinction doesn't come into play in any of your apps, any app that I've written myself either. But if you were to get a job, not just at Google, but at any company, you know, that does any kind of web application, whether it's a small or medium or large company or nonprofit, or I'm sure Brandeis as well, they will have this kind of stuff. Now, I bet Brandeis does not have a scaling out architecture. I bet Brandeis, I don't know if you know, but it's probably very complicated and manual and error prone. But that's scaling up versus scaling out. Okay. The next thing I've mentioned before is caching. Caching is a very fundamental computer science concept that's applied at all levels. And the simple most explanation for that is, given a request of any kind, subroutine call, database call, whatever, save the response so that if somebody makes the same request later, I don't have to compute the response again. That's caching. Next one is load balancing, and that's kind of what George was talking about, which is where you actually start deciding not simply round robin, but you're going to base it on other factors. Now, there's interesting problems. For example, sessions. Okay, if a particular user comes into the site and they have a session, then this load balancer sometimes has to worry about sending the request for that user back to whatever server they were on before, otherwise the session breaks. So this gets complicated. But load balancing is the general concept of identifying the load and making sure that you don't have one element in your system that's totally overloaded and another one that's not. And it comes into play with the load balancer in the most simple case, which is for HTTP, but it comes into play with databases and any other component in the system. All right. And then, of course, asynchronous processing, which is what we just did with the pusher. Okay, which is whenever something synchronous is things happen in a determined order. Asynchronous, they don't. And I'll go into a little bit more detail. Okay, so think about this. I'm going to just read off a couple of things to sort of to get you into the thinking about these kinds of problems in the right way. Okay, so basically, when do you have a scaling problem? Too many clients are asking the server to do a certain operation. Too many people are asking for a certain operation. Too many people are asking for a certain operation versus an individual person is asking for a certain operation too often, which is different and has a different solution. If 1 million people are asking for the same operation, the solution may be different than if you just happen to know that one person, one user, one client, one app is asking for too many of the same operation. There are different scenarios, and for tuning your system, you have to distinguish between those two. And then finally, a certain operation like making coffee in the Einstein's example is taking too long, in which case the solution is, can we make that operation faster? And these three cases are different, and you need to think about, when you're looking at a scaling problem, think about what case you have, because the solution you apply is going to be different. Okay, so let's go into, now we're going to get a little bit more down and dirty. So basically caching, it's clear, I talked about it, what it is. One of the problems with caching, very fundamental problems with caching is what? Where can things go wrong? If I save the result of asking the server where everybody is on my map and what's going on, and then I ask it again, and the server wants to cache it and give me the same answer. What can go wrong? Yes?
The answer isn't the same.
Yes.
It's different.
Yes. Is there a word for that? Anybody know the buzzword? Cache expiration, cache validity, validity management. So basically it's exactly, the problem is that. And not knowing anything else, you can just time it out. You can just say, okay, this particular response in my cache is going to be good only up until, time t. You can also, another thing people do is least recently used. So in other words, you keep everything in the cache. When you run out of space, you start throwing things out of the cache. You start invalidating the cache for those entries that were used the longest ago. But basically, the validity of the cache at any moment in time is critical in two directions. If you invalidate it too quickly, if you say everything lasts only for 100 milliseconds, well then the benefit of the cache is reduced. If you invalidate an entry too slow, then of course you might be returning incorrect information. Okay? So memoization, I mentioned that very quickly. I'll show that in another example. Joe, are you with us?
Yes.
I showed memoization in another example. Memoization is doing that at the method level. I call square root of 4, and I don't have to compute it every time because I know that whatever answer I gave last time is going to be good forever. There's examples of ways of calculating factorials that take advantage of the fact that whatever answers I've given so far, I don't have to compute again. I can just start from there and go on. That's an example of memorization. So whenever you know either the result you're looking for has been asked for or a result before can be used to shortcut the new result, That's all examples of memorization. Works only within one process, within one application, within one memory space. It's a very, very elementary, easy to implement technique. It should be in all of your toolkits because it can make major differences in the right situations. Then you have system level caching. Okay, now basically the system level caching can be something as simple as a snippet of HTML, right? I mean, if every time I draw a piece of the screen, it's going to be like the piece of the screen that has the user's image, but the user's image is coming out of a database, an image database, and it gets converted and resized and prepared. Well, then I could cache a bit of HTML, so whenever that user or anybody else asks for the profile for that user, you don't have to go through all those steps. Now, you don't want to leave that work in the cache forever because people do change their images. Plus, you have a huge amount of memory you're tying up with all those images. So there's still a cache exploration thing, but now we're talking about a system level cache. Okay, and where can that stuff be stored? Now, remembering that all these systems have multiple servers, and by the way, I haven't even said that there's a disk on all these computers. There's actually maybe another set of computers, 9 and 10 and 11, which contain the file system, right? Files. And so these things are all interconnected on the LAN. So, the information can be stored obviously on system level files across your whole infrastructure. They can be stored in a database. Often databases like Oracle or MongoDB are used for caching. Very common for REST APIs, which have a set of parameters in the request, and the result is a huge and expensive to calculate block of JSON, that request and response gets cached, so that you don't have to go, you don't have to go traverse a bunch of databases to construct a big response, because if everybody's asking the same thing of your REST API, you can cache that in the database. So it could be in the file system of the system, it could be in the database system, like MongoDB or SQL database, and it could also be in the cloud. So in the cloud, that means basically there's another service, and I cite here, Amazon. They have one where your caching is happening there. So there's a lot of places it can be stored. A term that you hear often in this context is name value databases. These are databases that do just that. They're like the equivalent. I mean, they're just like a hash in Ruby. So you can just say, store at key blah, 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 value, blah, blah, blah. Okay, and that's all they do, but they do this extraordinarily fast. Key value databases are Redis. We talked about Redis the other day. Another very common one is Memcached. So I have links to all these things here for you to look at. But so caching can happen at the program level, in memory, on disk for the server, on disk for the whole service, and in the cloud. It's all the same principle. Okay. Asynchronous processing. What do all these things have in common? All these different operations that I listed here. What do they all have in common? Ready? What do they have in common? It's not a trick question. It's a simple answer. Steve? They all can be slow. That's all. Any operation, I told you it's not a trick question. Any operation that can take, here, this is just a rule of thumb, more than 400 milliseconds should never be done directly in the request-response loop. Should never be done synchronously. Should never be done as part of the controller. So if I request the server, this Rails or anything else, if I request the server to do X, send an email, resize an image, check for spam before my email is sent, whatever, before my email is displayed. If my request to the server to process that request can potentially take more than 400 milliseconds, it should not be done synchronously. It should be done asynchronously. Okay? The difference between the two? A synchronous request is a call. and the caller waits until the answer comes back. So I'm going to say somebody asks for a password reminder. Request password reminder. Press OK. The user presses OK. The controller runs. Is he going to initiate sending an email then and there? Talk to the server and so on? No. Because that is definitely possibly going to run more than 400 milliseconds. Okay? You upload a new image for your profile. And before it gets stored in the database, the semantics are that all images are reduced to a certain size. Do you do that after they press OK to save their profile before you store it in the database? No. Because you don't want to wait. You don't want to block the request, make the web browser not refresh while you wait for that to happen. You want to do that asynchronously. Okay? So synchronous, the caller waits for a response. Asynchronous, the request returns right away, and the result comes later, somehow. That's asynchronous. Okay? Because remember, the web server, all they do is respond to HTTP requests, and that's what we're doing. Make it go fast.
Can active record reads be done asynchronously?
No.
Like if I were to write JavaScript that on page ready sets inner HTML to be like separate pages. Like if I had JavaScript calling to render pages and those pages required database calls, how would it handle that?
Well, think that through. Once you're running JavaScript, you're on the client. That's where the JavaScript runs. There ain't no database anywhere around there.
But JavaScript can fetch a page.
Index. From where?
Well, let's say I have a view that's like a partial.
Yeah.
And I have JavaScript fetching that partial, and on that partial is content being pulled from Active Record.
No, I mean, we have to take your case in more detail, but the basic overarching fact is that the JavaScript is running in the browser, and the database is not anywhere there. So the JavaScript, so your use case is a little bit wacky, because once you can run JavaScript on the server, but that's a special case, and that doesn't really happen in Rails at all.
Well, that's not what I'm talking about. I mean, you can definitely have JavaScript render pages.
Mm-hmm.
And you can have pages that call information from.
Let's go through it offline.
Oh, okay.
I mean, in other words, you have to refute my statement, which is JavaScript is in the browser, the pages are not there. It could request a new page, but then still that page is getting rendered on the server.
Right, but I just meant for the perception
that
of if you have a page that requires a lot of database calls, rendering as much of the page as you can, and then doing the database calls and inserting them with JavaScript.
It would end up looking something like what I showed with the inner HTML stuffing the values in, but it would still happen. The database work will still happen on the server. Now, to change your question around a little bit, and say, can Active Record be used asynchronously? Well, yes, it can. Huh?
That was my question.
I know. So I'm going back to that question because the use case you described doesn't do it for it. But I give you a way in which it does do it. I haven't talked about this yet, but I could write an app. In fact, some of you will have this. In your mainline Rails program, you might have a special class called background notifier. Okay, class. And it's going to have a class method called send notifications. And in order to do this, it's going through the database to find who needs a notification and initiating some way to notify them. Okay? And that, sorry. Okay, so for example, let's just say that it's the Piazza thing. When anybody updates a note, it'll send emails to people who subscribe to it. Okay? So every so often, let's hypothetically say, like every minute, the Piazza server, which I don't even know, I think it is written in Rails, has to go through and see who has, what notes have been updated, who has subscribed to them, and then send them emails. That definitely could be using Active Record, And it could be accessing the database, and you have to worry about race conditions in that case. And this could be happening in background, asynchronously, because this whole method is not getting called as a result of the request-response cycle. It's getting called as a result of a clock, of time elapsing. And that's a very legitimate and real-world example where active record is being called asynchronously. I don't know if this is the case you had in mind, but since I just see I'm out of time, I'll stop here and pick up where we left off on Friday. But before you go, we'll talk off in a minute to sort of understand the case you're talking about. Don't have to remind you, Thursday, the reviewers are here. I'm available, if necessary, through email or phone call if you need some help. On the Thursday homework sheet, essentially, homework page, I indicated an idea of how the day is going to, or the 2 hours are going to go. So one of them is to prepare a demo, right? So you guys to prepare a demo, 5 or 6 minutes, that just shows what you've done in the best possible light. Okay? Everybody's going to do it. We're going to do it before the class, before we break up. I have about 35 minutes or something like that assigned to that. Okay? It's all written up. If you have any questions or concerns, talk to us. Thank you.
Thank you, everyone.